In case 4, we are dealing with improper fraction, improper rational functions. Improper means the degree of the polynomial in numerator is equal to or more than the degree of the polynomial in denominator. So in denominator we have x times x, which is x square, so the degree is same. In this case it's same. And if you look at the second example, degree in the numerator is 3, degree is the highest power, and in denominator is x times x, so it's x square, so degree of the polynomial in numerator is 1 more than degree of the polynomial in denominator, so it can be equal or more. So this particular case is not in P3, so we are not going to discuss this example. This will just give you the idea of the pattern in which we make supposition. So I'm going to discuss the first example, which is the case of equal degree. So this is 3x square minus 7x minus 18 over x minus 3 and x plus 1. So the degree is same in this case. So the particular supposition we have to make is we have to let one extra constant a with the previous usual case with the linear factors. So if the factors in the denominator are linear, we simply let one constant for each factor in the denominator. So it's b over x minus 3 plus c over x plus 1. Now if we cross multiply, it's 3x square minus 7x minus 18 equals to a times. Now we have the usual work. So we can have a mixture of all three cases with the improper fraction. It can be a repeated factor or a quadratic factor, but if the degree is same or more, we have to let extra constants. Just like in the second example, we have a plus bx here. This is because we have the difference of 1 degree. So in the same pattern, we should continue to let the fractions. Okay, so we come back to this example. If we cross multiply, we get x minus 3 times x plus 1 plus b times of x plus 1, because we get the x minus 3 factor cancelled when we cross multiply the denominator from the left side, and then we have c times x minus 3. Now since it's an identity, so we can let any x value, any real x value. So I'm going to let x equals to 3 at first. So if I plug in 3 into it, I am going to get 3 square times 3 is 27, minus 3 times 7 is 21, minus 18 equals to, when I plug in x equals to 3 here, I am going to get a times 0 plus b times 3 plus 1, which is 4, and c times 0. This gives you 27 minus 21 is 6. Minus 18 is minus 12 equals to 4b, and the b value is minus 3. Similarly, for other constants, you can plug in other x values. Since it's an identity, we can plug in any real value of x. So I'm going to select minus 1 now, because minus 1 will help me find other constant directly. So I'm going to plug in minus 1. So it gives where I'm going to plug in minus 3 in this identity. So if I plug in minus 1 for x, I'm going to get 3 plus 7 minus 18 equals to, when I plug in minus 1 here, I'm going to get a times 0, b times 0, and it's c times minus 4. And this is 10 minus 18 is minus 8 equals to minus 4c. This gives us the c value equals to 2. Now for the value of a, we can assume any x value, since we know the other two constants, so any x value will work here. So I'm going to plug in x equals to 0 in the same identity again. So I'm going to get minus 18 on the left side. A times 0 minus 3 is minus 3 times 0 plus 1 is plus 1. And now I can plug in the b value, which is minus 3 here. and x is 0, so 0 plus 1. Similarly, we can plug in the c value, which is 2, and 0 minus 3, which is minus 3 in the end. We plug in c equals to 2. This gives us minus 18 equals to minus 3a, then minus 3 and minus 6. So this is minus 18 plus 9 equals to minus 3a, minus 9 equals to minus 3a, and a is plus 3. A is going to be plus 3. So the partial fraction is basically 3 plus, in fact 3 minus 3 over x minus 3 plus 2 over x plus 1.